Welcome back to the Scotti-BYTE channel, and this is Scott. So on my channel, I have covered LXD containers multiple times. In fact, I have several videos that discuss all the features and capabilities of LXD containers. But today, I'm going to step back and I'm going to take it from the beginning and explain LXD containers from the point of a beginner. LXD Containers 101. So LXD containers are like virtual machines, except they're fast, very lightweight, and have near zero boot times. LXD containers, like Docker containers, default to a private NAT network that is not reachable from your main LAN. We are going to learn how to present LXD containers on your main LAN that get unique IP addresses from your DHCP server. This will allow you to have a LXD host with multiple containers to isolate applications on their own dedicated IP addresses. There are a few considerations before we can start. So some of the prerequisites are that we will be starting with a host system that is running Ubuntu 2004. You can probably do this with other operating systems or other versions of Ubuntu, but for the sake of this demonstration, we're going to be using Ubuntu 2004 LTS. So the host is ideally a bare metal physical server and not a virtual machine. You can use an old laptop or an old desktop. Of course, the more memory available, the better. The more cores available, the better. Or you can even test this out on your desktop in order to configure LXD. Although if you're hosting applications, you typically want something that's going to be up 24/7. So we're going to be installing and configuring LXD. So LXD bridging does not work with Docker on the same host, or I should say it does not work properly. So we will discover that we can make one or more of our LXD containers a Docker server, which would be nested inside of a LXD container. And LXD, like Docker, creates containers on a private NAT network by default that is not reachable from your LAN. To be useful for hosting, we need LXD containers that are addressed on your main LAN and reachable from your main LAN. So that's where bridging comes in. We will be creating a network bridge device on the machine that we will be installing LXD on. If your host has a desktop GUI, we can use NM Connection Editor to create the bridge. But if your host is an Ubuntu server with no desktop GUI, we're going to show how to use NetPlan to create the bridge. Either method will work, it's just that the GUI method might be easier for some people. And the process in both cases is to create a bridge connection that will use your physical Ethernet device on your host system. Once the bridge is created, you will be deleting your primary Ethernet connection, and the bridge will handle all traffic to the LAN from your host and from LXD containers that are configured to use the bridge. So we will go through installing and configuring LXD as I mentioned earlier. And once the bridge is created, we can create a LXD profile to use the bridge. Basically, this looks like this. The commands to run LXD operations are the LXC, believe it or not, and that's a historical fact. Anyway, LXC profile create main LAN is what we're actually going to call it. And then LXC profile device add main LAN Ethernet 0. So device Ethernet 0 is the device inside the LXD container by default. And then we're going to tell it the NIC is a NIC type of bridged. And then the parent will be bridge 0. And bridge 0 is what we're going to create with NetPlan or with the NM Connection Editor. And then finally, we need to launch a container that uses the bridge. So LXC launch Ubuntu 2004 test will be the name of the container. We use profile default because that creates the root storage device for the LXD container. And we use profile main LAN because that tells it to bridge back to our bridge device. And then we put the switch boot.autostart equals true, which causes the system or the container to start up every time the system starts up. So your container will get an IPv4 address on your LAN, and if IPv6 is configured on your LAN, you will get an IPv6 address as well. You can connect to your new container via either LXC exec or SSH if OpenSSH container OpenSSH server is installed. And then we're going to show that we can install Docker on a LXD container bridge to your main LAN. Okay, so let's go do this. So here we are at the command prompt on my Ubuntu server, and it's Ubuntu 2004 LTS, and the address is 172.16.5.1, which is an address on my main network LAN. So the first thing we want to do to install LXD is do a sudo apt install LXD. Provide my sudo password. And LXD is installed. Now that LXD is installed, we want to add the LXD group to my user account with a sudo usermod -a capital G LXD, and my user account is Scott. Now we do a new group, LXD, and a groups. And you can see that Scott is in the LXD group. So now we need to do the first time configuration of LXD, which we do with the command sudo LXD init. The first question is, would you like to use LXD clustering? We're going to say no. Do you want to configure a new storage pool? The default is yes. Name of the new storage pool, we'll call it default. Name of the backend to use for storage, ZFS is fine. Create a new ZFS pool, we'll say yes. Would you like to use an existing block or storage device? The answer is no. Size in gigabytes of the new loop device. So the loop device is the largest size of a root file system will need, and 30 gigabytes is more than enough. So we'll hit enter here. Would you like to connect to a MOS server? We say no. Would you like to create a new local network bridge? We say yes. What will the name be? And we'll say we'll take the default of LXD BR0. This is the bridge that it uses to bridge the internal NAT LXD containers. And what IP address should be used. And auto is fine. I guess we have to type auto. And would you like to be available, would you like your LXD server to be available over the network? And I'm going to say yes. That way I can control it with something like LXD dashboard, which I cover in another one of my videos. And then address to bind LXD to, default is all, that is fine. And then port to bind LXD to is 8443 by default, and that's fine. And the trust password for new clients, I'll type in a password. And would you like stale cached images to be updated automatically? And the answer is yes. And would you like a YAML file for your init process to be printed? No, I don't need that. Now that LXD has been installed and initialized, what we need to do is a LXC list to see if we have any containers. Of course, we do not. And in order to start your first container, we have to do a LXD launch or LXC launch command. So this is a very simple command where we're saying launch a new container, make it Ubuntu, version 2004. The name of the container will be example. It's using the default profile, which tells it where the root file system should be stored. And then we say boot.autostart equals true, which means that when the LXD host boots, this container should start automatically. Now that our new container has been created and started, we can do LXC list, and we will see that this container is running. It's called example. It's located at IPv4 address 10.234.159.236, and it also has an IPv6 address, but this is a NAT address, meaning that this container can only be reached from inside, and it can communicate outside, but nothing on the LAN can communicate back to it. If you want to connect to this container, you would have to do LXC exec example bash, and that will go ahead and enter the bash shell, and there we are. When you get a new container, you automatically connect to it with LXC exec, and you get a root login. And we're going to do an apt update ampersand apt upgrade -y, because that's a good process to always perform on a brand new container. So now we have a fully updated container called example. And of course, you can go out and perform commands on this container like you would on any other. We can add users and we can install programs and everything you would do with an ordinary operating system. So if we do an exit and we do a LXC list, again, there's the container running at 10.234.159.236, but unfortunately, that is on an internal NAT network and not reachable from our LAN. So in this first example, what we have here is an Ubuntu server, so we don't have any GUI, we can't log into a desktop. So we're going to look at a couple of things. First of all, we can do an IP route show, and this will show the connections we have. And on the LXD host, you can see that 172.16.0.1 is the default route, and it goes through a device called ENS3. Let's do a sudo apt install of net-tools. And this will give us the ifconfig command. So if we do an ifconfig, we can see that we have a ENS3 is the name of our physical device. Your physical device will be different, but we know that this is our main device because it's 192.16.5.1, which is the address we started with in the beginning of the video. And you can see that it has a loopback device, and then this is the bridge. The LXD BR0 is the bridge that was created when we did the LXD init, and that's so that the NATed containers can talk out to the network, but not vice versa. So we want to change our main method of communication from a connection to the physical Ethernet device to go through a bridge instead. And we do that with a program called NetPlan, which is standard for Ubuntu. If we cd over to /etc/netplan, and we do an ls, you can see that there is a file called 00-installer config.yaml. And we want to do a sudo nano on that file. And this is the original configuration that gets created when you create a machine, or a server, I should say. And this server simply just says that the address of this machine is 172.16.5.1 with a 16-bit subnet mask. I mean, yours might be different, something like a 192 or 198 type address, 192.168 type address, and then there's a gateway, and then there's some name servers. So I'm going to go ahead and delete this. So I want to put a new file in here. And this file looks a little bit different because it basically says that we're creating a bridge called Bridge 0 that's going to bridge to ENS3. It still has the same address and the same gateway. And I'm putting name servers 1.1.1.1 and 1.0.0.1, which happen to be Cloudflare. And that's basically all there is to it. So I save the file. And now, in order to apply it, I do a sudo netplan apply. So if you were disconnected, you would have had to have logged back in. But now if we do an ifconfig command, we can see that ENS3 is no longer receiving an IP address. And if we look up here ahead of it, you can see that Bridge 0, the new device we created, has an address of 172.16.5.1. And this server is now communicating everything through its bridge, which was a prerequisite for LXD to use a bridge device. So now we're going to create a new LXD profile. And a profile can be used to use different networking is one of the things that it does. It does several other things. If you watch my channel on a regular basis, you'll see some of the other things we can do with it. So we have LXC profile create, and we're going to call our new profile main LAN. It's created this, and now what we want to do is do some settings for it. So LXC profile device add main LAN Ethernet 0, ETH0, which is the name of the network adapter inside of a LXD container, and then NIC type equals bridged, and the parent is going to be Bridge 0. And we just saw that we created Bridge 0, and Bridge 0 now connects to our main LAN. So now we've added that, and the last step to do is to actually create a container on the main LAN, and we'll do that with a LXC launch Ubuntu 2004 again. This time we're going to call the container test. We're using the default profile in order to point to the root file system, and we're using profile main LAN to be able to bridge to our main network and get an address on our main LAN. And again, boot.autostart equals true, because every time this LXD server starts, we want this container to start. Okay, now that this container has started, we can do a LXC list. And it doesn't yet have an address. Sometimes you have to wait a little while. If it's doing a NAT address, that's usually pretty quick. But if you're doing a bridged address, it's going to take a little bit longer. And you notice that both my container example there has an IPv6 address, and that's because I have IPv6 enabled on my network. So let's try to do another LXC list. And you can see that the test container has an IPv6 address now. And just a little bit longer, we should have an IPv4 address. Let's list again. And there you go. 172.16.1.212 is in fact on my main LAN. So if we do a LXC list to see both containers we created, and then we exit back out to my desktop machine, I try to exit to my desktop machine. There we go. So now I'm not on the LXD host, and if I try to ping 10.234.159.1 16.236, you'll be able to see that it is not reachable because it is on a NAT inside the network. However, if we turn around and we ping 172.16.1.212, this is the address of the container called test, which is presented on my main LAN, and you can see that it is reachable. So being able to bridge a container to the main LAN is important if you want to do self-hosted applications on it. So here I am back on my desktop machine, and I'm going to SSH over to 172.16.1.212, and it'll give me a, "Are you sure you want to connect?" And I say yes, and it says permission denied. And probably the reason it does that is because there is no Scott account on that particular machine. So in order to solve that problem, we want to go back here and connect to the server, and we'll do our LXC list again. We can do a LXC exec test Bosh, and I'll do an add user Scott. I'll give Scott a password. So let's add Scott to the sudo group with this usermod -a g sudo Scott. And then let's do an apt install of open SSH-server. And it says that OpenSSH server is already installed, but that came from the image, so you probably want to do an apt remove --purge of open SSH-server, and we're going to install it again with a new signature, and that way we should be able to connect to it. Now that it's deinstalled, let's go back and do an apt install of OpenSSH server once again. So let's do a LXC list. Let's exit out of the LXD server, and let's do an SSH over to 172.16.1.212. And since I have this account locally, which is named Scott, and I have a Scott account on the test server, it should provide me a username and password. So in this particular case, I must have used this address before on this host, so I have to remove the keygen signature in order to connect to it. So I do that, and then I do the SSH again. It says you want to create a new fingerprint. Yes, I do. I type in my password, and you can see that we are connected to the test server through SSH, which means, of course, it is reachable on the LAN through the bridge. So since we're signed on to our LXD container named test, we're also going to install Docker on it. And all these commands will be in the show notes, but this is the script to install Docker. It asks for my sudo password. So now that Docker is installed, we're going to do a sudo usermod -a capital G Docker Scott to add Scott to the, or add the Docker group to the Scott account. And then we'll do a new group, Docker, and we'll do a groups. So we've now installed Docker inside of a LXD container. Now that I have Docker installed inside of this LXD container, I'll do an if config, and you can see again that we have ETH0 172.16.1.212, which is our container. It now has a Docker device because we've installed Docker on that container, and of course it has a loopback device. So let's do a Docker PS, and there you can see that there are no Docker images running. So let's install a very simple Docker container, which is a whiteboard, and we'll just do that with the Docker run, detach, name will be whiteboard, it'll be port 8080 internally, and we'll expose that to port 8080 outside the network. Of course, I could use port 80 because this is the only thing running, the only Docker container running on this LXD instance, so port 80 is available. Anyway, it can't find the image, so it goes off to the Docker hub and it downloads whiteboard, and we'll be able to use it shortly. So an interesting thing is if we do a Docker PS, we notice that that container did not start, and if we do a Docker PS-A, you can see that the container was created, but it's not in the started status, and that's because of the error we received. And the reason we got that error is because we have not set up our original LXD container properly. So let's go change that. Here we are signed back into our LXD host, and let's do a LXC list and a LXC stop test. Now we want to modify that LXC instance to include a very special flag called the nesting flag, and we're going to set it to true. So LXC config set test security.nesting equals true. Also notice that the test container here has got not only its address on the LAN, but now since Docker is installed on it, we have the address 172.17.0.1, which is the internal Docker NAT address. Okay, so if we do a LXC list, we notice that our container is stopped. So let's do a LXC start test. We'll wait for a moment, and it should get its addresses back. So here we are signed on to our LXD host called test, where we have our Docker instance running. And if we do a Docker PS, there's no images currently running. So if we do a Docker PS-A, you can see that there's the image, but it has been created and is not correctly running. So let's remove it by doing a Docker remove and the container ID. Now that the container is removed, let's go ahead and create it again with the same Docker run command we used last time. Since we turned on nesting on this LXD host, the container was correctly started, and if we do a Docker PS, you can see that it's up and running. So again, as a reminder, if we do an if config, our address inside of this container is 172.16.1.212, and it uses port 8080. So if we go to 172.16.1.212 and we go to port 8080, there's our whiteboard up and running just fine. So back on the LXD host, as a reminder, if we do a LXC list, we have this example container running on the internal network. We have this test container which is presented to the LAN at 172.16.1.212, and we installed Docker inside of that container, And that Docker ran an instance of whiteboard which it's presenting out to the main network. So therefore, at 172.16.1.212 port 8080, we were able to display the whiteboard application. And the important fact here was that we had to have added the nesting to the container with the command LXD config set test security.nesting is true. Otherwise, the Docker container will not run properly inside of the LXD instance. So in order to configure the network, you can go into nm-connection-editor. And when you go in here, you're going to say, I already have it, but you see there's a bridge slave 1 adapter here. And what you end up doing is you end up going in and saying, I want to create a bridge adapter. And you can go off and say create, and then it will ask you to add a bridge connection. You can say add, and you can say you want to add an Ethernet connection. And when you do the add Ethernet connection, it will provide a drop down, and you can specify whatever the name of your adapter is, which I'm doing this on a different machine here, but that's what we do. And after we create and we save that, then we come back in here and you'll eventually be able to get rid of your regular Ethernet adapter in network connections. Once that's all done, if we do an if config, we will end up with a bridge. So I have a bridge 0 here that's running at my IP address. I also have a bridge 80 because I'm talking to one of my VLANs as well. But you'll notice that your regular Ethernet adapter is not getting the address. The bridge adapter is getting the address. And this is the same as if you do the netplan command, but that's the GUI way to accomplish the same thing. So, in summary, LXD containers are very fast and efficient. Bridging LXD containers to your LAN provides unique system instances running on dedicated IP addresses. And Docker should be installed inside of LXD containers where needed and not on the LXD host because of bridging conflicts between LXD and Docker. And you can have multiple Docker hosts if desired by installing Docker in each LXD container where needed. This provides superior application isolation and security. Anyway, thanks for listening today, and please subscribe and like to the channel, and we'll see you next time.